Hello everybody, this is Shiva and I'm a clinical SAS trainer working as a principal statistical programmer in one industry, and today I'm going to give the demo for how to create the CDISC standard SDTM datasets and CDISC compliant ADaM dataset, and how to write the efficient coding for the tables, listings, figures in SAS in the real-time project end-to-end projects. Most of the students, they have learned SAS, advanced base SAS, but they haven't completed their clinical SAS project. So what happened, in interview, the interview panel member, they will mainly focus on the clinical knowledge domain related things, and they will ask you the project related questions. If you are really performing well in your advanced and base SAS also, if you are not getting an idea about clinical SAS related things, you are not able to clear those interviews. So what happened, in my sessions I will explain you complete package, like complete project, how the real-time programmers do their in industry, how they involve in the project, how they understand the documents, how to write how they write the programming part and write the specification part, and with validate how they do the validation, etc. things. I will give you an overview in this demo. Okay, so we'll start the demo session. Here, my name is Shiva. I'm working as a principal statistical programmer in one of the MNC company, and I have 10 plus years of experience in this field, and I'm well versed with SQL, SAS, ICH. Also, initially I have a CRA experience, so I that time I dealt real time live projects also. So that experience will help you also. So that I will give those type of information whenever it requires. And I'm with a great online team from last 4 years as a successful trainer. I trained so many students, and most of them are placed in the industry. And here the course details. What the course details is, it is a 28-day to 30 days program. It's a daily 1 hour program per day, Monday to Friday, and I'll give the course materials like projects and recorded videos. If you are missing any class, so you can find it in the that class video, and I'll provide you the books and real-time project data. Yes, it is not a dummy data. I'm going to involving you people within the real-time project data. That is not dummy data. So what happened, what the real-time programmers do there in the industry job, we are in 28 to 30 days, we are, you and me are going to finish the real-time project with client specification and statistician expectations. And after training also, we'll give the job support with some minimal charges. So our aim is to trying to get you into the industries. Okay, students can attend multiple batches until they get the job. Okay, here today agenda is, after this session we are able to learn what is the flow of projects, all the therapeutic area, any type of project, what is the flow in industry, and I'll give the over idea about what is SDTM, what is ADaM, and how to create the TLFs. Here, this is the flow. Flow means this is a structure. First, whenever we started any type of clinical studies, we have to understand the raw data set. Some companies, they have a separate team called CDM, Clinical Data Management Team. The team is completely working on the raw data related things. So once we understand the raw data set, our actual work will start. As a clinical SAS programmer, we can start our SDTM dataset thing. Later, once we finish creating the SDTM dataset, we can use the SDTM dataset as a source dataset for creating the ADaM dataset. Once we finish our ADaM dataset, we can use this ADaM dataset as a source dataset to create the TLFs, tables, listings, and figures. So, what are the core contents, core procedures used in the each and every corner? You can see in the raw dataset creation. If in CRO, in our CRO, we don't have any CDM team, what happen, we need to extract the data. Otherwise, client directly given sometimes the raw data sets to you. Most of the 90% CDM team is working on the raw data set creation and provide you the raw data set information. The raw data set information nothing but while going the study, clinical study moving, the investigator or the doctors will give you all the information into the paper case report forms. Those case report form, all the values, they will enter into the data sets is called raw data set. Raw data set, raw means it is a unfurnished data. So what the actually the clinical study was done and what is the information is collected from the paper CRF is just put into the data set and given us to create the SDTM and ADaM and TLFs. So that is the raw information. As a clinical programmer, what we have to do in the raw data set creation step. So first of all, we just understand the raw data CRF. So we have a CRF filled and unfilled CRFs are there. So we can observe as a clinical programmer, we can observe each and every section and you can understand which information was collected. What is the purpose of collecting all this data? If it is an oncology study, is it really collecting the oncology related things? If it is an ophthalmology study, it is really collecting the ophthalmology related information. So which therapeutic area it is and what the information is collecting in the raw data sets. We should understand and you can imagine how the study was conducted, phase 1, phase 2 or visit 1, visit 2, week 1, week 2, how the subject was involved in the clinical study. We can observe by seeing the raw data set CRFs. And once we can understand the raw CRF, we can see the dataset extraction process. Which dataset extraction process were used in CDM people? Some are, some small scale industries, they just entered all the data into Excel sheet and writing the proc import procedure to get into an SAS dataset. Some big CROs or MNC companies, they use some softwares. So the softwares, the data entry people, all this data they will enter into the software and the software deal everything and they will create the SAS dataset. So this is the process. As a clinical SAS programmer, we are not going to do anything in the raw dataset. Sometimes even 10% chances are there. Sometimes small scale industry, that time we need to apply our proc import procedures to get the data from paper CRFs to Excel sheets and Excel sheets to dataset creations. In SDTM part, as a clinical programmer, the actual work will start here. And these are 5 steps involved in the SDTM process. First one is we need to annotate our eCRF. Annotation means nothing but as per the CDISC standards, where we have a documents called implementation guide. In the implementation guide, what the variables they mentioned as per the CDISC standards, we just mapped with the raw variables. Which variable is preferably suited for that variable, we just mapped. That is called annotations, and SDTM eCRF annotation is the one role of our clinical SAS programmer. And second one is understanding the SDTM implementation guide, which is prepared by the CDISC people. So every SDTM dataset finally should be CDISC compliant. Then only the USFDA or any regulatory will accept your SDTM datasets. And based upon this implementation guide, we just prepared our specification documents, how the derivations happen for each and every variable we just mentioned in the specification file. And based upon the specification file derivations, we just create our SDTM program, write our SDTM program and create our SDTM dataset. Each domain have a separate dataset. So writing the SDTM program, we can create our dataset and we can map every data, raw data, which was fitted to any one of the SDTM domain. Once we done the domain, DM domain, we need to validate the dataset. So that time there are two process. First one is proc compare method using parallel programming method, and another one is we have a validated tool that is called Pinnacle 21. We just pass all the dataset XPT files to this tool, and they will cross check everything whether all the variables are CD standards or not. If it is not, they will give you an Excel sheet report. In that report, mention that which variables are not as per the standards. Based upon this Excel sheet report, we can update our program to comply with our CDISC standard. Once we created and validate our SDTM dataset, we can use this SDTM dataset source for creating the ADaM dataset. What is this ADaM dataset? Based upon the implementation guide provided by the CDISC people for ADaM also, we just create our ADaM variables and ADaM dataset as per the CDISC standards. And there are 4 steps. First of all, we need to understand the ADaM implementation guide. Later, we can create our ADaM specification file. So in that, every variable, derivation, etc. things we mentioned. Later, ADaM dataset programming based upon the ADaM specification file derivations. And later, we can validate our ADaM dataset by using either Pinnacle 21, either parallel programming. So what is this ADaM? Because tables, listings, figure, the statistician wants to analyze something, and that information is there in the SDTM. We have an intermediate step called ADaM. So in the ADaM, each and every variable which are required for the analysis, we can include that into the ADaM dataset. So no derivations are going to happen in the tables, listings and figure level. We just count percentages or summary statistics, p-value related things we are going to do in the TLF level. Any derived variable must be deriving the ADaM level only. So every programmer, they can use the ADaM dataset and create the TLF or validating the TLF. So ADaM is the main concept. Which variable is not present in the SDTM, which is required for the TLF analysis, we are going to put into the ADaM dataset as per the ADaM implementation guideline, rules and regulations and CDISC standards. So once we created all our ADaM dataset, we can move to our TLF generation. The mark shell is provided by the statistician. So based upon the mark shell requirements, we just write our programming part to create the tables, listings, figures. And once we develop our output, the QC programmer will check manually either parallel coding, partial coding, some other methods they can use for proc compare, and will validate. Once we validate and every numbers are getting right, then we can move to all these things to client, and client statistician or a third person, they will review and they can submit to the USFDA. This is the overall process. So in my training, what I have to do is I'll take the data, raw data sets, and we can start our SDTM programming, ADaM programming and TLF programming. Each and everything I'll write a scratch code from beginning to end in front of you in the classes, and I'll explain you each and every step, why I'm writing that step, what is the importance of that step, and whenever it is used, and what is the interview question behind that one, and how the interviewer may going to ask the questions while going the classes. Each and everything I'll explain. The specification file writing in front of you only. I don't want to copy anything. I just write from the scratch everything in 28 to around 30 to 30 days it will take. So one by one step I'll cover. I'll explain everything in to you, and I'll give some homework sessions, how to create by your own, etc. things I'll explain you. And I'll give an overview idea about each and everything here. See, first one is what is the raw CRF, case report form. Here, this is a blank CRF. In this, if the clinical study is ongoing, the investigator or the doctor must fill all these details like which each subject has separate CRF. So they will mention what is the sex, whether he is a male or female, and what is the ethnicity, what is the race for the particular subject. So they will enter all this information. This is a one page of CRF. So there are so many pages for each subject. Throughout the clinical study, the investigator or the doctor is filling everything. So this is the information was raw information. So from the raw CRFs to we are going to extract this into SAS dataset. This is the first step. We can understand the CRF, raw CRF. Later data extraction was happen. I already explained you. Some softwares used for some MNC or some big company. Here extract OC Oracle Clinica softwares and Open Clinica. These are the some two softwares. They can extract the paper CRF data to SAS dataset by CDM department, clinical data management people. So the data entry people enter all this data into the software, and this software will create the SAS dataset. And some small companies, what happened, they just entered everything into the Excel sheet, and by using this proc import procedure, they'll create the SAS dataset, and we can also use the SAS dataset. Which method was using not a problem. As a clinical programmer, we just want raw information. And once the SAS dataset extraction, you can find out here, you can see this is a filled CRF data and this is a data set. Here, the data set information for the first subject, you can find this first subject is male, 20 years. You can see S1 subject is male and gender is male and age is 20. Height 175 centimeters, weight 59 kgs, 19.3 BMI kg per meter square. You can find height 175 centimeters, weight 59 kgs, BMI 19.3 kg per meter square. In this way, the dataset extraction was happen, and once the dataset extraction was happen, we can cross compare with the filled CRF with the dataset also. Once the dataset extraction was happen, SDTM part. SDTM is nothing but study data tabulation model, and in this 5 core areas: implementation guide, annotation CRF, specification file writing, dataset programming, Pinnacle 21. So in my sessions, I am going to cover each and every section in detail. So I am giving the overview. So first one is SDTM implementation guide. So here this is the implementation guide prepared by the CDISC people. In this, each and every variable, every domain information you can find. Here I am searching the DM domain. Here, demographic domain. So each and everything, demographic details, or what are the variables they want to include in the DM domain, and which label was, which length, and etc. things they mentioned in the control terminology. Based upon the control terminology as well as implementation guidelines, we just go through the every section. This is the implementation guide, and this is the annotation CRF. Here you can see this is the annotation CRF. Here the annotation CRF for this one, which raw data set information is fitted for which CD standard variable. Here you can see there is a birth DTC variable, age variable, and age units and sex variables are there. So this is the CD standard variable, and as per the raw CRF, which was suited. Here age was suited for this variable, sex was suited for this sex raw variable, ethnicity is ethnicity, race is race, birth DTC is belongs to the this one. So as per the CD standards, we just annotated our CRF which raw information is fitted for which CDISC variable. This is the annotation part, and later we are going to create our specification file. Here this is a specification file. we just copied everything information from here, variable label, length and control terminology and core, etc. And we are writing the programming derivations, how to create, how to map this variable to which raw variable, and if there is any derived variable like usubjid or etc derivations, we just write here programming derivation part, and we are going to write it in the programming part. So these are the three one, and next one is here. This is a specification file. For example, one variable is there, usubjid, and this is going to create study ID, site ID, and subject ID concatenation. This information also you can get in the implementation guide. Here you can see study ID, site ID, and subject ID concatenations. How to implement it in the programming? See here you can see subject ID, study ID, site ID, and subject ID. These are the variables we are going to concatenate as per the CDISC rules and regulations, and each and every variable we just check with the implementation guide rules, and based upon the raw data set we are going to map our SDTM CDISC standard variable. So in my sessions I'll write the code in front of you, and I'll explain you each and every variable importance, and whether it is required for our study. If it is required, I'll give full information. If it is not required, wherever the variable is required, I'll explain you in each and every data set and each and every variable. This is this one, and so many SDTM data sets are there, and as per all the data set comes under these 6 classes: interventions classes, events classes, finding classes, domain classes, trial design, and relationship. Here these are the 6 classes. So I'll take in my sessions, I'll take each and every category one data set, and I'll write the specification file as well as annotations and programming part for each and every variable. I'll explain you in detail. So in each class I'll take one data set and explain you in detail. Okay. And once we done our SDTM dataset, we just validate by using Pinnacle 21 tool. So this is the tool. This is a validated tool, and we just here you can see draft files here to select the item. So just drag all the SDTM XPT files. I'll explain you what is the XPT files in my session. You just drag all XPT files into this tool and click on the run button. It will check the CDISC implementation guide rules are applicable. All the variables are properly aligned, or properly mapped to the standards or not. If it is not, they will give errors or warnings with one Excel sheet report in detail. So we will check this report and we will update our program for the requirement. And once we done our all SDTM dataset, we validated, we can move to our ADaM dataset creation by using the source as SDTM dataset. And here the 4 parts are there: ADaM implementation guide understanding, writing the ADaM specification file, ADaM dataset programming, ADaM dataset validation. Here here also, like SDTM implementation guide, we have an ADaM implementation guide. Here analysis data model implementation guide. So in this also each and everything variable, how to create and how to derive, etc. rules and regulations is there in this one. And based upon the TLF requirement, what are the ADaM dataset required, we just created those ADaM dataset with required variable. And here this is the specification for ADaM dataset. Some are derived variables are there, some are assigned. So based upon the TLF requirement, what are the variables required for analysis, we just check all the mark shell and we can create the derivations and programming in the ADaM section. Here you can see one example I am showing. The safety population flag we are writing in the specification. Why we are deriving this safety population flag? If you go and check the mark shells of the tables, they mention like safety population needed. So in case of SDTM, there is no safety population information in the SDTM dataset. And we have an SAP document, statistical analysis plan documents provided by the statistician. In the document, he will mention every derivations with detail what the expectation of the statistician for their review, for their analysis. So we can check with the SAP documents for the derivations, and based on the derivation we can write our specification file for the particular variable, and the variable naming convention and the rules and regulations should be followed in as per the implementation guide of ADaM prepared by the CDISC people, right? So here safety population and the derivation is there, and programming is like writing like this. Whenever the safety population derivation is nothing but which subject has at least one treatment, those people consider as safety population. So writing the programming, EX dose, exposure dose was not missing, and exposure start date not missing. Those subject we can include in the safety population. This is a programming. In this way, each and every derived variable we have to write it in the ADaM programming, create the ADaM data set. Why? What is the use for this creating this flags? This should be used for the TLF generation. And here I am going to cover this all ADaM dataset specification as programming, and whenever I am going to create any derived variable, I'll show you where it was going to use in the TLF. Each and every section, each and everything I'll write in front of you ADaM derivation programming also. And finally, how to create the TLF. Based upon the Marshall understanding, create the TLF programming. Once we done, validate the TLF out. Once we done our ADaM data sets also, we can validate by using either Pinnacle 21, either parallel programming. Okay. So here you can see this is a TLF mock shell, and the statistician wants to include safety population in this section and test reference overall they want. And for this one we just proposed in the programming either proc summary or proc min for n mean median statistics. This is the basic code. We can build up so much code for the requirement of getting the required TLF shells. So once we get the programming, we get the counts like this as per the mock shell, same mock shell, but wherever they mention some excess, sorry, we get the values here. So I'll explain you how to write the programming by looking the TLF mock shell, and finally we just create our TLF as per the mock shell. That is our aim. And once we done our TLF, we just write the parallel programming, either partial coding or manual checking the counts with this one and applying some logic whether the counts are getting right or incorrect. We can check, and I am showing just proc compare method for ADaM dataset. Parallel programming is nothing but the same programmer, two programmers are there. One programmer is developing the dataset, and another programmer is writing the same programming and creating the QC code. And finally, by using the proc compare method, we just compare both the dataset. If both the datasets are fine, the values are matching, it is passed to third review. Otherwise, we can write, we can get the comments, and based upon the comments, whether the comments are fine, we can update our programming and we can pass the QCR, finalize the output. And this is the thing. Thanks for attending this video. Please contact, if you are really interested to join my sessions, please contact this number here for training. Contact Balu, and this is the email, and you can contact for my next batches. Thanks for attending this class. Thank you.